Module 3 ADAM-6000 and ADAM-6200 series. Here is the outline. First, we will talk about the basic information about ADAM-6000 series. Second, there will be some new features. Last, we will talk about IEEE 802.3 standard to understand the communication interface of the ADAM Ethernet module. After you finish this module, you will be able to perform the following tasks, such as understand the product family, specify module's I/O type, familiar with all common features. Last, you will be able to understand a basic network communication knowledge and a corresponding conversion port and protocol in our ADAM module. Here is the hardware overview of ADAM Ethernet module. There are two connectors, which is located at the top and the bottom of the module. The LED indicators in the middle provides the information such as I/O status and the communication status. The communication protocol are Modbus TCP and Advantech ASCII. On the right side, there is a frame ground screw, which is for protection. The most important is that the ADAM-6000 has only one LAN port, while there are two LAN ports in ADAM-6200 series. Just like ADAM-4000 series, ADAM-6000 series can be divided into three groups, including analog I/O, digital I/O, and the relay output. ADAM-6200 series is the same as ADAM-6000 series, can also be divided into three groups. This slide is the naming rule for ADAM, which can help us to identify the type of module by its module name. The first two bits means the protocol. 60 and 62 are both Modbus TCP, while 61 means special protocol, such as Ethernet IP and Profinet, and we use C bit to specify the protocol. The third bit stands for the module type. 1 is for the analog input, 2 is for analog output, and 5 is for digital input and output, and last, 6 is for relay output. This slide summarizes the difference between ADAM-6000 BE and the CE version. A quick way to check the hardware version is to see the firmware version of the module. If the firmware is older than version 5.0, it's BE version. And if the firmware is newer than version 5.0, it's CE version. The new added functions are listed in below and will be introduced in the following slides. For ADAM-6000 DIO modules, due to the key component is phased out and no longer supplied by vendor, ADAM-6000D is released to replace the older version. ADAM-6000D is designed to be compatible with ADAM-6000 CE in pin assignment and functions. Furthermore, some specifications are enhanced and new features are added. The main enhancements are listed in the belowing table, such as MQTT protocol and SMMP protocol. It is important that users have to upgrade firmware and utility to see these new functions. Now, we are going to talk about the common features of ADAM-6000 CE and ADAM-6200 one by one in the following slides. First is the DHCP function. As you can see in the picture, you can enter the IP by clicking Static IP checkbox. When you need DHCP server to assign IP address on ADAM, you can click DHCP checkbox. Remember to press Apply button to apply the setting. One of the new features of ADAM-6000 CE or higher version and ADAM-6200 is user-defined Modbus address. In order to provide user with more flexible and scalable in applying ADAM module, limitation of Modbus address setting has been removed, which made it configurable for users' need. By double-clicking the address, you can modify the Modbus address based on the application. Next is the Reset to Factory Default function. User can clear all configuration and setting by using ADAM.NET utility. It's convenient for user to reuse module for a new project. For ADAM-6000 CE or higher version and ADAM-6200, there is built-in web server based on HTML5 that can be accessed by using a standard web browser. By entering the IP of ADAM module, you can see the I/O status through the browser. Remember, you have to log in web server by the username and the password. In certain application scenarios, it's necessary to set multiple modules with the same setting because these modules are doing the same task on different sites. Customer might have to configure the module with the same system configure file, firmware, and HTML5 to all modules in the same network. The group configuration function can help you configure all settings to multiple modules just with one click, which means that you can configure many modules at one time. It is important to know that ADAM-6000 and the 6200 series modules only allow 8 connections. It means that 8 host computers can access data at the same time. This is because when access ADAM via internet, the communication quality is not always 100% good, so the connection will not always success. If encounter communication failure, the connection on ADAM-6000 series will not be released immediately. It will be released after TCP IP timeout. So, if communication failure happens over 8 times, user cannot connect it to modules anymore. The solution is we can set the host idle time in utility. The default host idle time of ADAM is 720 seconds. ADAM will detect the connection is under communication or not. If not, when the host idle time is over, module will release the connection automatically. Now, let's focus on the features of ADAM-6200 series. The main feature is the daisy chain function. Since there are 2 LAN ports on ADAM-6200, it's easy to connect multiple ADAM with daisy chain, just like the picture below. To ensure communication stability in daisy chain structure, ADAM-6200 have auto bypass protection, which means if one of the ADAM is abnormal or broken, data can still pass to another ADAM without being interrupted. The group configuration function also allows user to configure multiple modules at the same time. In other words, user could update firmware to all modules in the same network by using group configuration function. Compared to ADAM-6000 series, there are I/O LED indicators in the ADAM-6200 series. User can know the I/O status easily by the I/O LED on module front panel. The Modbus address is also addressable in ADAM-6200. Besides, it offers an intelligent control ability with GCL, graphical control logic, P2P functions, which will be introduced in detail in Module 6. Let's see the daisy chain connectivity in the following picture. For ADAM-6000 series, there is only one LAN port. So if a controller wants to connect to multiple devices, you need a switch for extending LAN port. And if the distance is over 100 meters, you need another switch to enhance the signal for connecting another ADAM. However, in daisy chain topology, it's easy to connect all ADAM modules simply with the LAN cable. User can save the cost for buying the switch and the internet cable. The drawback for daisy chain topology is that if one of the ADAM is broken, it will cause the entire communication interrupted. To prevent this problem happening, we designed an auto bypass function. So if there are some modules broken in the middle, the communication can still work properly. The auto bypass function can last for 4 days. There are limitations of auto bypass function, which will be described in the next slide. This slide explains the auto bypass limitation. As you can see, the auto bypass function can only have 2 consecutive modules broken in the same network, without making the whole network not working. And the total connectivity distance of auto bypass must be shorter than 100 meters. If there are 2 consecutive ADAM devices broken, the distance between each module must be shorter than 33 meters. Besides, users need to have enough private IP address to assign each module. For example, if user only have 254 IP address, the max number of modules in daisy chain in the same network is 254. Let's see how the auto bypass function works. When it's in normal status, port 1 and port 2 connect to an internal switch. When there is a power outage, TX and RX of these 2 ports will connect together automatically. That's how ADAM prevents communication being interrupted. The auto bypass function can recover the network after 2.5 seconds, and it can stay for 4 days when there is a power outage. So users have time can replace the failure module during these 4 days. Next is the LED indicator, which is convenient for users to observe the I/O status in the spot. Besides, we also designed a function for you to locate the working module in a spot. If you enable the locate function in utility, you will see the LED continuous on for 30 seconds. This is because when using DHCP mode, it's hard to identify the module by its IP address. So we can use the locate function to help you find the working module. For some AI or DI module, users need to use switch to choose the mode of the input signal. For example, in AI module, you can switch to detect voltage or current. In DI module, you can switch to detect dry contact or wet contact signal. Since ADAM-6000 and 6200 series is Ethernet module, let's introduce the Ethernet communication, IEEE 802.3 standard. It will help us to better understand the communication in ADAM. For ADAM-6000, ADAM-6100, ADAM-6200, they all use Ethernet for communication. Internet is very popular in today's society. With Ethernet interface, ADAM is easy to communicate with other devices. It can also communicate with the device in another country, which provides customer a great convenience for cross-region project. As you can see, we use the OSI model to describe the process of communication, and it can be divided into 7 distinct groups of layers. The EEE 802.3 Ethernet is referred to the first and the second layer of the OSI model. Now, let's start from the bottom layer. For the first layer, physical layer, it defines the electrical and the physical specification of the data connection, such as using like RJ45, fiber optical, or coaxial for physical transmission medium. For the second layer, data link layer, it uses a basic frame for data transmission. This layer sets out links across the physical network, putting packets into network frames. You can see the picture in the middle of this slide. Each frame includes the target MAC address, also the source address. Ether type means that what protocol is for the upper layer, and last one is a CRC error checking code. The CRC checking code helps to check the data correctness. If there was a problem happen when transmission data and cause the checking node mismatch, this data packet will be dropped off. For the third layer, it's responsible for packet forwarding, including routing through intermediate routers. So the routing protocol is in layer 3. Let's talk about the transport layer. This is where the device establishes the connection with the controller. There are 2 protocols here, TCP and the UDP. For TCP, it's a connection-oriented protocol, which has a fixed path for packet transmission. And it also has the 3-way handshake function to make 2 devices confirm the connection. The way for connection is to send a SYNC command to the receiver. The receiver will also send an ACK to inform the packet is received, then send a SYNC to the sender. After receiving the SYNC from the receiver, the sender will send an ACK back to receiver to confirm the packet is received. That's how TCP building connection. If both sender and receiver is working properly, after TCP connection is established, there won't be data loss during data transmission. So TCP can ensure each data is sent to the destination without losing packet. As for UDP protocol, UDP do not establish connection between devices. So the sender will only send packet without caring about whether receiver received the packet or not. But the advantage of using UDP is that the transmission speed is fast. Now, let's see the example of pulling Modbus TCP data. The picture shows the network packets on your LAN card. 10.0.0.123 is PC's LAN IP. Also is the address where ADAM.NET utility requests for establishing TCP connection. 10.0.0.51 is the IP of ADAM module. As you can see in the red box, there is a 3-way handshake to establish TCP connection. After the connection is established, utility may start to pulling Modbus TCP data from ADAM module. Here is the UDP example of how ADAM sends UDP data to the host PC. As you can see, there is no three-way handshake for sending data, which means UDP does not need to establish connection before sending data. In ADAM, there are three ways for data transmission, which is data streaming, P2P, GCO function. All these three ways do not need to set up connection between ADAM utility and the ADAM module. Let's talk about the error recovery mechanism for TCP protocol. The TCP protocol can guarantee reliable delivery of data, and it uses the acknowledgement and retransmission timer for achieving this goal. Just like this picture, if receiver didn't receive sequence 2 but received 1 and 3, it will send ACK 1 to tell the sender to retransmit the sequence 2. After receive sequence 2, it will send ACK 1 to 3. Then the sender will start to send sequence 4 to the receiver. Let's see the upper layer in OSI model, the application layer. As you can see in the yellow block, it is responsible for applications communicating between hosts. Below are the examples of common application protocol, such as Modbus TCP, HTTP, and so on. Here we will talk about the OSI 7-layer encapsulation concept. All communication on a network originate at a source and are sent to a destination. So the picture here have the source system, the sender, and the destination system, the receiver. The data from the sender will encapsulate layer by layer until it reaches the lowest level. As you can see, the data will have a header in the front, which contains the protocol information of each layer. For example, the L7H is the protocol information for the data in layer 7. When the data moves down to the other layer, each OSI layer adds a header to the data before passing it down to a lower layer. That's why you will see more header in the lower layer. As the data go down the lowest layer, it is transmitted by 0 and 1. This downward process of the data is called encapsulation. Conversely, the data to the receiver will de-encapsulate layer by layer until it reaches to the destination layer. The upward process of the data is called de-encapsulation. When the data moves up to the upper layer, each OSI model will remove the header from the data. So when the data reaches layer 7, receiver can get the original data sent from the sender. That's why you will see less header on the top layer. It is really important to understand how data transmitted in Internet, especially when troubleshooting network problems. Since we can narrow down the communication problem to a certain layer, and we can also see where the problem is. This slide shows the different protocol and the port used in ADAM modules. Here we list the common function of ADAM. User can check which protocol the function used and its port number. For example, if user want to use the P2P function of ADAM, user need to check the port number is 1025. Otherwise, the P2P function cannot work due to the wrong port setting. If a user wants to use a SCADA software like Web Access to access the I/O status of ADAM, the communication protocol between ADAM and SCADA is Modbus TCP. He needs to enter port number 502 for data communication. That's all for Module 3. Thank you.